它也有一个教材，这个教材呢其实是有一个电子版，到时候看这个share给大家，就是关于他们存储语言方面的这个教材。这样可能主要因为他讲的内容会比较宽泛，比较基本，所以说呢可能不完全是按照教材上写，所以说呢它是有很多的这个 PPT， 大家记都有了哈，都可以开始了啊。有看好。
Yeah, almost. Yeah.
Okay. It is my honor to introduce Professor Jean-Pierre. And this is the first lesson of this class. Okay. And from today, we have several talks in the next days.
Okay. So, hello, ni hao, and welcome to this series of lectures on formal methods for embedded system design. Before to start, I'd like to thank Beihang University, Professor Ma and Professor Hu for inviting me and for organizing this series of presentation. My name is Jean-Pierre Talpin, and I work at INRIA. INRIA is a national institute in France, which comprises approximately 4,000 members, and they are represented in 8 major research centers in the regional capitals of France, and they are organized as 200 research project teams. A research project team is usually a small laboratory who is focused on a specific research problem. In the institute I work in Rennes, called IRISA. We are approximately 600 people, and so I address 30 project teams. And the institute is shared with the University of Rennes, with CNRS, and the INSTA graduate school. So the project team I work with is called T. T is an acronym for Time, Events, and Architecture. Our focus is on defining formal methods to aid engineers in developing safe embedded systems. Our principal focus is on correctly modeling time during the process of designing an embedded system, and specifically from an architecture perspective. So the research we perform is supported by a toolset, an experimental toolset, which is open source and available as an Eclipse project called POP. POP stands for Polychronie on Polarsis. During this series of lecture, I will introduce you, give a complete introduction on polychronie. And the aim of this experimental toolset is to serve as a framework to support formal methods that might be useful to help designing embedded software architectures. So what is Polychronie of Polarsis? So it is an Eclipse framework and Eclipse interface of the model of computation and communication we call polychrony, which is itself implemented using a data flow language called Signal. And this this framework allows us to use Signal more as a set of services that will be that the engineer will be able to use individually in order to help him with tasks of engineering like program transformations, formal verification, or code generation. And it's all available at this address here on the Eclipse project. So this is where I work and with whom I work. Now about myself. So I'm graduated from University Paris 6, and I did my PhD at École des Mines de Paris, near this beautiful garden of Luxembourg in Paris. After my PhD, I visited the European Computer Industry Research Center, which is located in the very nice city of Munich. So I joined ECRC as research associate, and I worked there approximately 3 years. And I joined INRIA in '95 first as a member of a project team called EPATR, which is at the origin of the Signal language I mentioned. And then I led the continuation of this project team called Espresso until last year. And last year we decided to start a new project team with a different and more focused scientific goal, which is modeling time for embedded architectures. I'm also